Distinguished colleagues, we're beginning the panel session for the defense of the thesis of Andrei Kudlis. The thesis is submitted for the academic degree of the candidate of Sciences in Physics and Mathematics. The specialization is 010402, Theoretical Physics. The topic of the thesis is Multiloop renormalization group analysis of critical behavior of models with different symmetries under the order issued by St. Petersburg State University. I, Mikhail Nalimov, from St. Petersburg State University, have been appointed the chairperson of this dissertation board, and our members of the board include Nikolai Antonov from St. Petersburg State University, Dmitry Aristov from Kurchatov Institute, Vladimir Prudnikov from St. Petersburg State, from Omsk State University, and Michal Gnatich from Košice, Slovakia. So we all know each other, therefore I believe I won't give you the full titles. And our candidate for the degree, Andrei Kudlis and Alexander Sokolov, the thesis supervisor for Mr. Kudlis. And distinguished colleagues, we all worked in remote mode. We all know how to turn off the microphones. So I would like to inform you that our panel session of the dissertation board has been recorded and broadcast on St. Petersburg State University website and interpreted into English. So those who are listening to our broadcast can ask questions. There was a specific email address given, and all the questions will be submitted to us. So we have a quorum because all the 5 members of the board are present. We have our agenda. I won't read that through because that just take too much time. And I can say what's important here is that our candidate is given 15 minutes for his report. Then we have no more than 2 minutes for each question. If we want to ask questions to our candidate for the degree, the members of the board will be given 10 minutes each, but I believe we won't take this 10 minutes. So that is it. We have time for open discussion. We have time for questions from those who are not members of the board and those who want to speak out and to ask a question. We have a registry form here, so you should fill it in before you speak out. Well, that's it about the important things. The questions, any questions on our schedule, on our agenda? No questions, okay. So, the thesis by Andrei Kudlis was approved for the defense July 20th. So we have this number of the order. The thesis, Mr. Kudlis has prepared his dissertation based on St. Petersburg State University. Mr. Sokolov is the supervisor. We have 7 publications in high-quality journals. And as for our procedure, the preliminary defense on the department was organized as well, and the department liked the dissertation. The full package of documents was provided to the secretary, to the academic secretary, by our candidate for the degree. All the documents are in conformity, and the copies are found in the certification file. So that's it. As for documents, do we have any questions on the documents? No questions, okay. Well, so 15 minutes. Andrei, please, you have the floor. Distinguished colleagues, once again, good afternoon. Distinguished chairperson, distinguished members of the board. The report I'm going to present today is on the topic of my PhD thesis. The research area of my work is the critical behavior theory. The dissertation was written under the supervision of Alexander Sokolov and Mikhail Kompanets. So the slide shows the outline of my presentation, and I'm going to have some historical background on the field of scientific knowledge. Then I'll switch to the relevance of the study, and then I will dwell upon the objectives of my thesis. I will say a few words about the methods used in the work, and the major part will be dedicated to the findings of the research. And finally, we'll have the findings for the defense. So the critical phenomena mean the processes observed in the system when the system is approaching the so-called critical point. And physics is quite rich here, and as for peculiarities, we have universality. Different systems may demonstrate a different critical behavior if they are in one class of universality, and this class is characterized by some fundamental characteristics like space, the dimensionality of space, symmetry, spin, dimensionality, and spin. The first theory that managed to describe this transition was the Landau theory, and he proposed to function. He used the order parameter and offered a kind of scheme to get on the limitations that we get for these coefficients. For example, in quadratic case, A should depend on t minus t critical, and using this functionality we can get the full set of critical indices that are used to describe denominators in these thermodynamic parameters. So a few years ago, Lars Arzagan offered presented a solution to the two-dimensionalizing model in zero external field, and the resulting indices, however, differed from the given Landau theory. Then several attempts were made to find exact solution for three-dimensionalizing model, but a solution has not yet been found. However, answers to this model can be obtained using various approximate methods, including the Monte Carlo calculations, as well as high or low temperature expansion techniques. So this was done, and three-dimensionalizing model was analyzed, and the results that we got were different from two-dimensionalizing model, and it was observed that getting such indices, we can compile a kind of correlations that were called scattering correlations. And these facts led to thermodynamic hypothesis, and here we talk about tau and h. Tau is t minus t critical, and h is external field. The Landau theory works only with this value, and the thing is that Landau theory works just with the mean value, and it does not take into account the fluctuations of parameters that are growing in approaching with critical temperature. And there was an offer to switch from average mean and from Landau functionality to next step. And Wilson, as Wilson demonstrated, strong fluctuations can be taken into account using the renormalization group methods. So the most well-known and studied action here in the field is the scale of field model, Phi4. And over 30 years ago, this model generated 5-loop expansion. And after that, an analysis was carried out of this model using different symmetries, and for them, scientists also obtained some quality methods and quantity characteristics like critical indices and so on. So, and finally, after that, there were certain developments, but there was a kind of break, a pause in the development of this sphere. And as for the breakthrough, the calculation performed by Mikhail Kompanets and Eric Panzer, so they published a work, and they obtained a 6-loop expansion for the model, and this made the analysis of a range of goals quite relevant. Here I'm referring to the goals of the thesis, and thus the thesis resolved the following tasks. The analysis for cubic model, for chiral model, and for impure and fraction space dimensionality model. And separately, there was yet another additional task to analyze thermodynamics and free energy for generalized Heisenberg model, and it was implemented in the framework of renorm groups in three-dimensional space. Shortly, how do we carry out analysis? First of all, for any physical system, we correspond efficient actions. Maybe it can be based on some symmetries or on some micromodel. Then, knowing the action, we can get different green functions, some series, and so on. And when we use specific integrals, we'll see discrepancies that can be eliminated by redefinition of parameters of model and field. And the so-called Z multipliers are also used, and the final action has no such problems as discrepancy. So switching to the results. So as I've already mentioned, I analyzed the cubic model. You see the activity. And this model describes critical behavior of cubic ferromagnets, for example, ferrum or nickel. And you can also see T1 and T2 tensor factors for QN symmetric option. And for this model, we calculated 6 loop expansions. So renorm group expansion for beta function, epsilon for coordinates with fixed point, and also expansion for grid indices. And as other scientists, we analyzed renorm or group flows. So there are 2 options here, and the option depends on the scale of spin components, on the dimensionality of the order parameter from this n parameter. And if n is higher than certain border marginal value, then we will have the regime demonstrated on the right part of the image with an isotropic critical behavior. And if n is smaller than nc, then we'll have isotropic or Heisenberg critical behavior. So it becomes clear that nc is the critical parameter of this model. And the thing is that basically this value is in close proximity with the physical interesting order parameter of 3, and for this nc we got epsilon expansion, and it was resummed differently, and we gave assessments that we received in the summary table. We used also some alternative renorm group approaches and different orders, and the final values are stably smaller than 3 in 6-loop mode, and these assessments were also included here on the graph in order to see the change in assessment for this parameter. And due to the relevance of analysis of this cubic class of universality, we got the assessments for critical indices, and also a separate goal was to analyze anisotropy of a magnetic perception of cubic ferromagnets, nearly 8%. And the main conclusion to be done here is that ferromagnets with cubic symmetry should have anisotropic regime of critical behavior, that is, that can be documented in real physical experiments and in numerical calculations. Chiral was the next model that we analyzed. The activities are more interesting. T1 and T2 are tensor factors that correspond symmetric and chiral factors, and this model describes critical behavior in ferromagnets with non-collinear and non-coplanar spin ordering. Ferrum fluoride was also used here in the second case. In the first case, we had the so-called triangle ferromagnets, layered ferromagnets, and here the situation is a bit more interesting. Here I'm referring to the scenarios. 4 scenarios are given here, 3 values, 3 border order parameters, and when is this regime stable? When this chiral critical point is stable? We're interested in that. So we got different results for different n values. You see different expansions for n plus and minus, and in h epsilon expansion they were resummed, and that all was placed on this stability diagram. And we should mention that finally I'm going to comment on that, connected with one of the reviews of other members of the board. So what can be said here? The white area corresponds to the phase transition in chiral phase of the second mode. The gray is the phase 1 transition. So the physics for n and m that are higher than 2. So no chiral character can be observed if n and m are smaller than 2, and this part can be considered as an canonic approach in just the analysis of epsilon expansion. Then numerical assessments certainly are the most interesting for n+. You see this upper border here, and they were included in the table as in cubic model. And you can compare the results that we got using alternative renorm group approaches and in smaller orders of the excitation theory. So the main result is that our assessment was smaller than 6 in non-collinear R-type, and in non-complenar type the assessment is from 9 to 10, and this can be considered as a kind of mathematical game. And we got assessments for critical indices for relevant classes of universality. So what that is the conclusion to be made on based on n value, and we compared them with the previous results. So the main conclusion is that shift to chiral phase for real ferromagnets with non-collinear and non-complenar types when n parameter equals 2 or 3 should be the phase 1 type transition, and studying the chiral universality class becomes relevant when n is higher than 6 and m is higher than 10. Or when n is higher than 10. And we analyze the impure Ising model. This micromodel looks like that. Epsilon is non-correlated random numbers taking the values of 0 and 1. So we had certain impurity, or it's absent. So you see fluctuations here, and using the replica methods we can switch to the analysis of cubic model, and in order to do that we can just use the dimensionality that equals 0. And we did it, and it turns out, and we knew that, by the way, that the system of equations on the coordinates of fixed points are pronounced. You can't get a traditional epsilon expansion, but a number of authors offered a mode to get this root of epsilon. That's an alternative expansion. We did it, and we got such expansions for critical indices. We analyzed this expansion and got certain assessments for critical indices, and they completely contradicted, and that's not surprising. And we also try to use some modifications to analyze initial renorm group series that we got with minimal subtractions, and we used epsilon that was equal to 1, and resummed beta functions and got 2 areas of possible values of coordinates of fixed points. Each of the areas was taken into account, and we got the critical indices, and alpha was negative. The marginal area is quite huge here, and nu and other indices were rather close to the values that we got using other techniques. And another thing to be mentioned is that this class of universality, including the Ising class, is different from the impure class. So the conclusion, as I've already mentioned, the alternative technique of resumming allowed us to get rather good assessments for critical indices. And we also analyzed fractional space model, and it allowed us to perform the analysis of the Ising model in fractional space. So you just use epsilon that does not equal 1. So what was the stimulus for this work? Using the conformity bootstrap, an Italian group with one Japanese subject calculated these indices using other theoretical field method, and we, as we knew the current epsilon expansion, we did just the same, but here you see that the axis combines with approximation that was created based on the assessments using the bootstrap method. And here we got 3 indices for nu and omega. And here I'd like to make a comment on one of the reviews, on the comment of Mikhail Yurievich. So your time is running up, so I believe you should continue your report, and as for comments, we'll switch to them later. Okay, and the last task was to analyze the critical thermodynamics for the Heisenberg model, generalized Heisenberg model we got. So that was interesting for us, universal effective relations higher than these connection constants, and we got random group expansions for them and got the following values. For G8 we got 4-loop case, and you see the calculations on the slide, and for G10 we got 5-loop case. So we summed them up, and the thesis gives a lot of numerical assessments. For example, here I calculated for R8 for different order parameters using different methods compared with previous parameters, and the conclusion is that for R6 and R8 everything looks good, but for R10, due to this structure of series, we did not get any numerical assessments. So we did the calculations but didn't get the results. Maybe we need certain higher orders to be taken into account. So the findings of the research are the construction of the theory of critical behavior in the 6-loop approximation for cubic and chiral models, the construction of critical behavior theory in the same high order of perturbation theory for impure and fractional model, fractional space Ising model, random group analysis for Ising models, and multi-loop analysis of universal relations for the generalized Heisenberg model in the framework of renormalization group and space of physical dimensionality. So that's it. Thank you. Any questions? Well, if there are no questions, I would like to switch to my answers. Well, I have a question. What are the goals that you considered, except the ones that you had in chapter 6? So 6-loop approximation is quite enough, and further improvement of 7-loop type won't give us anything, I believe. So once again, is it expedient to calculate 7 loops? Yes, and the considered goals from chapter 2 to chapter 5, where can you be limited with 6-loop approximation and believe that next orders, forthcoming orders, will generate no results? Well, it seems to me that that's pure philosophy, and it will take too much time to answer. For example, yes, we can be we can stick to 6 loops, and we can answer, for example, that. And that's a kind of sport. You never know what next order will give you. Yeah, yes, but compared with 5 loop that they started before. Okay, I'll try to answer. Well, I believe as for cubic model, everything looks good already. And as for the chiral one, and we have a certain pathology here that I'm demonstrating in the expansion, maybe the 7th loop would give us something more interesting. Maybe. But I can't guarantee that. We haven't calculated it. Well, for chiral. And what are the order parameters? Okay. So where do you expect the improvements? So that's the poor structure here. If you have a look at this series n minus when n equals 6, you see the pathology here. And this pathology may have an impact on assessments. Maybe it would be eliminated by a higher order if you compare the coefficients given here and the regular behavior. For n minus, if n equals 6, the coefficient does not behave that well. You see the gap in regularity and also not just factorial growth, but that's quite superfactorial growth. Yes, when we see the growth of number of components of parameters, one of the series may deteriorate. Certainly, yes, it may, but okay. We believe that the next order improves our accuracy, and that's what we believe. I won't give a more serious answer here. Thank you. Other questions? No questions? Okay. Okay. Then I can inform you that we did not get some external reviews. Luckily. And we shift to the members of the board. The reviews are published on the website, so don't read them, but you can just say a few words about your relation, about your comments, about your reviews, and I have a list here. Nikolai, please, you have the floor. Yes, in alphabetical order. So I believe you hear me. Indeed, I want to read out my review, and I won't give you the content of the dissertation because everything is written quite well there, and it was presented correctly within the framework of this limited time that we had. What I want to mention is that the thesis creates a very good impression. It is a fundamental one. So everything is considered in details, different approaches, epsilon expansion, pseudo-epsilon expansion, and renorm groups in the fixed dimensionality space. So everywhere we use the maximum 6 loop results in epsilon expansion, at least, and we see the summing up everywhere and detailed comparison with existing results with the change in results compared with the previous 5 loop approximation. So everything is done correctly and fully. So the text is also quite clear and quite full, regardless of the fact that that's quite a harsh topic. It's still easier to read because the author repeats the necessary information in each chapter. You don't have to make a leap back in order to remember what was described before. So he explains his everything with calculations, and historical overview and literature overview is also given. And it seems to me that this makes this thesis a good methodological object. That is an original scientific research. Certainly, the results should be the basis of further research, and maybe the author plans to continue the studies. I believe there are 7 loop results, but maybe not that reliable right now. But it would be interesting to consider what's going to change if we add up the next component. Will this answers be stable in this case? So that's how I see the answer to the a question of Vladimir Vasilievich. So add up other members and have a look whether we're going to see certain changes, and if so, we need to study 8 loops. So I have no remarks, no serious remarks. There were certain misprints, but I believe I won't mention them. And as for the results, it seemed to me that the most interesting was to see this marginal value for n in a model with hypercubic behavior, because, as the candidate explained, in the approximation of 3 we have this value that is most interesting, and it's really obvious that the critical value is higher than 3, and that defines the type of critical behavior. And there we also have the discussion of these anisotropic perceptions that demonstrate that there are very close indices in isotropic Heisenberg point and in hypercube point, though experimentally we can hope that we can see the difference between them in order to support this theoretical conclusion. And yet another point that I wanted to mention, well, there are questions that arise on the epsilon expansion, but to this double dimension, to this 2-dimension mode, and there is certain a discrepancy between the approaches. And overall, that is the issue on the 2-dimensional model of Phi4 and Ising model. Do they have the same critical behavior? So that is the question. And quite recently, we've seen interesting results. An article by 2 Italians and 1 Japanese that says that there is a certain transition of conform structures that define the critical behavior in approximation to 2. The thesis covers the issue, and it turns out that there is certain discrepancy in results of different approaches, and I believe this should be a stimulus for further studies. Overall, I believe that this thesis meets the requirements of the order. St. Petersburg State University it has a very good scientific, it is performed on the very good scientific level, it generated good results, and it should stimulate further research, theoretical and experimental ones. So I believe that Andrei deserves the academic degree of the candidate of sciences and physics and mathematics. Thank you. Thank you. As far as I see, you had no comments, and there are no need for answers. So, Dmitry, please, you have the floor. Distinguished colleagues, I won't read out my review as well. Indeed, my first impression was that I was really surprised by the amount of work carried out by Andrei. Indeed, that's quite very good language of the dissertation, very good demonstration of results, very good overview of literature. Everything was quite all right, and overall I agree with the previous speaker that one of the most important points here is to define the critical dimensionality of field in approximation to 3. And that is the statement given by the dissertation, and I believe that is an important fundamental result that the scientists got. It is described in chapter 1. And if we talk about the need to calculate other loops, indeed we are to think if everything is okay, well, then we shouldn't do that. And if there are any questions left, then that is that should stimulate further studies. And at the same time, I want to disagree with this advantage of the thesis that each chapter has the same repetitions. Every time when I read the thesis, I thought, oh, what's that? What did you add the same repetitions? Therefore, I commented on that. That's on the. These are the following. So numerous tables really merge with the text. I believe you should have done it differently. There are numerous abbreviations are used, but they are explained later, so you don't explain them at once. I've seen them in the PDF file, and the key abbreviations, they are introduced on page 138. But you start so you explain them on page 138, but you start using them on page 37. So you use the same text fragments in each chapter, and every time I read the next chapter, I found the same texts. So I understand it personally because the person wrote articles and then had to put them, these texts, in the dissertation. Certainly you had this duplication here. Maybe you could have avoided that, but when I assessed the scope of work you performed, I said, okay. But that's a bit annoying. And the last point on the content of the thesis, it seems strange to me, and I want to hear the comment on that. So Andrei has already mentioned that in the chiral model, when we consider the ON-OM system, initially we have symmetry for this N and M indices, and we say, for example, N is more than M, so that that's how it was given in the thesis, and then we carry out certain calculations and generate certain results and get the phase portrait of the system. But at that point, initial symmetry regarding the indices is something that we no longer see on this portrait, and this was what I wanted to mention, and I want Andrei to comment on that. Certainly. Yes. Indeed, the initial actions have this symmetry on the replacement of N and M indices, and I can say the following thing. First of all the renorm group expansions for this model, we've checked them, and they have the following symmetry on the rearrangement of N and M. The second point to be mentioned is that when we construct this phase diagram, stability diagram, not phase diagram, when we construct this stability diagram, when we resum, we stick to absolutely regular scheme, universally adopted, and as we discussed, that from the very beginning up until the end, this route is so long that we didn't have enough time to consider the entire diagram. And as for symmetry, it is quite symmetric, and that is why. First of all, you should consider the scale. We have 18, 0 to 18, and here 2 to 6. And second point is that, frankly, if we are based on the fact that n plus is the true assessment and not use all the n- assessments that we got in the resumming procedure, then here we may have a kind of white spot. Yes, that's what we can get. And we can say yet another thing. This characteristic that we observe here can be kind of an indicator where we can apply the epsilon expansion method where we lose the symmetry. So epsilon expansion is inapplicable there. And yet another point to be mentioned is that the chiral character is present for n and m higher than 2. And here we have no contradictions. And also this point should have been reflected in the work somehow, and we should have mentioned that so that it wouldn't bring in some discomfort that you don't see the white point here, white line here. So that is the answer that I want to give. So I'm satisfied. Yes, quite satisfied. Mikhail, can you turn on the light? Yes. Yes, we don't see you quite well. Well, I'll give it a try. So it seems to me that it's light enough. Yeah, that's better. Thank you. So, Vladimir, you have the floor. Yes, thank you. Well, I have a very good impression on the thesis. And I really thought that if this dissertation would have just chapters 2, 3, and 4, this would be even enough for the thesis. But at the same time, I understand that Alexander was working on the impact of cubic anisotropy before these works. Therefore, there's a kind of confirmation of the previous results at a different level. And Alexander, as far as I see, really liked working with Andrei, and he wanted to study more, considering the time restrictions that he had. So I have a very good impression on the work, and I would like to particularly emphasize that the use of different renorm group approaches and epsilon expansion and pseudo-epsilon and spatial effects dimensionality and the application to the series of theory and the use of different asymptotic series in this regard, that's a very good school for the candidate for the degree, because he got quite varied skills and he will be able to apply them in his future studies. And overall, I was impressed by the results from chapters 2, 3, and 4. Certainly the questions that you answered in chapters 5 and 6, they're also interesting, but they are mostly aimed at future and at the specification in the future. And from the point of view of certain comments, well, I would say that you do not analyze which of the methods of resumming for series is better. So you don't have this comparative analysis of the resumming methods for some or other goals. And above that, this introductory chapter, that's it's so short that you should have taken it out completely and give it as and add it to the chapter, to the second chapter. That's what I believe. And these repetitions that were already mentioned before. So you could have done, arranged it more in a more compact manner with references and links. That's what I wanted to say. But it's clear that, judging by the results, I believe that the thesis really meets the requirements of the order and meets the requirements of the St. Petersburg State University, and Mr. Kudlis deserves the academic degree of the candidate of sciences and physics and mathematics. An answer, yes. Thank you very much for this feedback. Vladimir, the first chapter, this review chapter, it was thicker, it was larger, but when the thesis has expanded and expanded, therefore I had to cut, and certainly I should have cut it out and put it to this second chapter. Yes, I agree with you completely. Yes, certainly you had this opportunity to shorten the text. Yes, some 5 or 6 pages. Yes, I agree with that. I should have cut more. Thank you. So, Mikhail, please, you have the floor. Thank you. Overall, I have a simpler task because the members of the board has already given their opinions, and also I have just same views. And overall, that's a very good work with a lot of details. And what I want to emphasize that as for calculations of 5-loop diagrams, that's a very complex work, that's unique work. You should look for new methods, and you see calculating 6 loops, that's really a good thing, and I mentioned it in my review, and the candidate said that there was a kind of stagnation for 30 years, and that's a kind of breakthrough to calculate 6 loops here. Then there is a kind of description on what was done on the chapters. I won't read it, but I want to emphasize that the goal is quite relevant, or the objective of the study is quite relevant, and in this regard, 6 loops mode, it's a kind of, competition to find new methods. Sure enough, these are theoretical and experimental methods, and certainly the dissertation has demonstrated scientific novelty and has practical value. And really, I can't analyze a lot of information, and the parameters of critical behavior in these results allowed to improve the accuracy of assessments mentioned, and to carry out comparative analysis of most state-of-the-art methods. And then I won't read that. And I would like to emphasize the validity, because you see, such results can be easily checked, and here I emphasize that this validity is defined by 2 major factors. First of all, for a range of problems, the author used several alternative renorm group approaches, and second, in the goals, we have comparative analysis of the results, the comparison with other theoretical methods, and within the framework of physical and calculation experiments. And all results were reported on several international conferences, and I participated in these conferences. He really had very good presentations, and the results were also published in high-ranking journals. And as for comments, I have just a few of them. I won't read them because I've written them down already. Yes, I have them on the board. Okay. I hope Andrei will answer my questions, but overall there were certain comments with this liberal treatment of terminology, and today he also said that Wilson used quantum field renorm group for calculations. Certainly he used his group. Yes, certainly. And also, as for statements on classical field theory, that is equivalent to the Euclidean field theory, so I would be accurate about that. And the overall comment is on the specifics, a definition of certain values. We can guess certainly that you missed this Z value and B parameter. So, and you do not define this critical dimensionalities of the order parameter in the chiral model. And overall, there are some misprints, but they do not strain the sense. That's why I want to emphasize that overall, these comments do not compromise the high assessment, the high mark of the thesis, and the thesis by Andrei Kudlis on the topic meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Kudlis deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 010402 theoretical physics. Thank you. Thank you. So, Andrei, you have the floor. Yes. I'm going to comment on the use of alternative resumming methods to series, but we decided to use the most canonic ones because we were limited in time and because we are restricted by the volume of the thesis. Certainly we could have used hypergeometric functions, but maybe in the future this could be done. And the next point was on this terminology, a liberal use of terminology. So here I'm referring to the fact that for classical goals of statistical physics, we use the methods of quantum field theory. That's what I meant. That just misinterpretation of this wording. Yes, we use theoretical field approach. That's how we call it. Yes, I use the same. Yes, that was a kind of synonym here. Yes, classical theory, classical field theory is something, you know, quite a novelty. Non-electrodynamics, yes. Okay. Yes, I would give this provocative comment. This equation of Gelman law. Could you please comment on that as well? Did you understand the question? Yes, I did. How can we say anything without the calculations? For example, we resummed without epsilon. For example, some other alternatives methods may include a three-dimensional style, but I don't think that I can add anything else here. What were you talking about? So, are you satisfied with the answer? Yes. Yes, you did not use this equation. Okay. Any other comments? Or just these two? So these are the others were just really the same as the previous ones. Okay, so it's my turn. So a lot was mentioned before. Therefore, I just won't repeat that. And I would like to mention just the fantastic, detailed historical overview, and I would like to mention this, the content of the thesis that exceeds the average thesis that we see, and so that's quite a lot of work done. And I have quite a range of reviews, though you won't have to answer such comments frequently. Yes, I have. So give it here because I just want to comment with my own words. So repetitions. Really, when you have such a such a size, you just want to you just don't want to reread it all over again. So there was a discussion on the orders to be calculated. I can say the following thing: 15, roughly 15, and that's due to the fact that the figures will change weekly. But I was always interested in this accuracy issue, the accuracy and the error. And part of my comments is connected with that. So the first thing to mention is that once getting 4 orders in thermodynamics, well, we were the first to get them. We did not calculate them ourselves, but we carried out the resumming using the majority of well-known methods. And the results were quite interesting. The errors were assessed. They were not overlapping. We had just an overlap of errors in modes that use the asymptotics of for bootstrap, and that's really resumming using the singularity, well-known singularity. And these 2 intervals of probability overlapped, and in other cases we didn't see this overlap of errors. And all these methods equal when we have this asymptotic. That's what I don't see here, and I want to mention that. Just one moment, I will finish my comment. So here we use varied approaches, and their comparison gives us the existing error. And that's my first comment, that in chapter 3 you don't use the conform bootstrap. But that's not a comment because it was mentioned that you didn't have time for that. Certainly it's clear that you had certain order of works and methods. Second point was that you don't have this fixed point, and that's not an indicator of the first class transition. You always say that, everyone says that, but you never know what it actually means. So you need to calculate this functionality of free energy. I believe you can just agree with that and say nothing. Yes, I can just add. And maybe you'd like to comment on the results of comparison with 2. And here I'd like to mention one thing as well. There is a very old article. Mr. Vasilyev was my thesis supervisor, and this article was published in Leningrad State University Herald, and it considered the issue using value 1 to calculate the epsilon expansion, and they used 3 and then fractions that were approaching 2. And through these dimensionalities, the indices just jump to this analytical continuation. And 2 is an exception here because that's a point of exclusive dimensionalities. And using this approach to describe the results of 2, it's impossible to do. But this expansion on a different parameter demonstrates that other dimensionalities should be covered correctly. That is why we can talk about lack of Helens here. And overall, as I've already mentioned, when you use such parameters, such approximation parameters, so here I don't trust these results when you use fitting parameters, because you choose more convenient schemes with good parameters, and this can lead to lack of overlap in errors. So these are my comments. You maybe wanted to add something, and I interrupted. Vladimir, yes, I tried to interrupt, but you've given this correspondence with dynamics of critical events and statics here. They give different series, and approximation is quite different. Yes, but we have work with a company on dynamics, and it demonstrates that there is the same behavior of series. Well, our experience, and also in full loop approximation, we were the first to get. Yes, I know we refer to your article, but those were not full loop or epsilon expansion. Yes, we can bring it to the discussion. Yeah, I got distracted a bit, you know. And as for your comments, as for lack of IR point, certainly we can't say that this phase will be stable, and we should analyze the appropriate potential of free energy. And as far as I know, we didn't have this analysis for chiral model, but this analysis was performed for superfluid helium-3, and this analysis was carried out for tetragon crystal. We don't have stable points there, fixed points, and we observed a leap in phase transition. So I can just thank you for the comment and say that I need to calculate that. And as for the assessment of applicability of epsilon expansion, certainly we should have been more accurate with conclusions and divide 1 and 2. When we have 0.5, we have this detectable discrepancy in assessments. That's the first conclusion, but it means nothing about the fact that epsilon expansion stops being applicable. Certainly we see that up until 1, and then it behaves quite well, and we can get some relevant results. Maybe I should have been more accurate still. And in conclusion, I should have mentioned that there are certain issues on the procedure of resumming and on the mode of assessing the error. So there's quite a lot of questions here. That's it. Thank you. That's clear that when you have such a scope of dissertation, certainly you would have certain gaps. You can't do anything at once, everything at once. So anyone willing to speak out on the thesis? Anyone not from the members of the board? No? Seems that no. Any external questions? Did we receive them? No? Wonderful. So is everyone satisfied with the replies of our candidate for the degree? Yes? Okay. Please, thesis supervisor, Alexander, you have the floor. And I believe you shouldn't. Well, I wanted to comment, and that, you know, unlike the old requirements of the attestation commission, when supervisors couldn't talk about the thesis, you could just talk about the person, because when you talk about the person, you describe the achievements of the person. So I'm going to talk about the dissertation as well, not because it's just wonderful, but considering the cubic and chiral model, that's a kind of a detective story, and this detective started long ago, 50 years ago. The thing is that the first low loop results received in 1 or 2 loops demonstrate that in cubic ferromagnets, you should have the transition that is different to a Heisenberg model. So this critical dimensionality mentioned, it was calculated in 1 loop, it was full, more than 3, and in 2 loops it was much smaller than 3. Therefore, judging by the first results that we have in Wilson's theory, it was quite unclear for 3-dimensional ferromagnets that you can put on the table how much is this figure here. And many years ago we used 3 loops, and in 3 loops there was a leap over 3, so we got 3.003, so we nearly reached 3, and it became clear that the cases in the number of loops and 3 loops were insufficient. And when we started using 4 loops, this NC dropped lower than 3, 1/10. It was 1/10 smaller. 5 loops demonstrated that it remains there. And in the year 2000, we simultaneously calculated 5 loops and Italian 6 loops, and got 2.9. It's close to 3, but smaller than 3. And formally, this ferromagnet should not be described by Heisenberg model, and it was created for it, frankly. And there is a kind of a dramatic plot here, and Andrejs' work is a kind of continuation of this investigation. And as for the chiral situation, it's getting even more interesting. In 1 loop and in 2 loops, scientists considered the behavior of chiral magnetics, and they declared that there is this chiral class, and from several loops it means we see that it exists. We see this phase 2 transition with a set of critical indices, and they're different from others. And in 2004, Serge Antonenko and I calculated 3 loops and got that this chiral class of universality goes beyond 3. So these are not vectors, these are hypervectors, and we have models where they can be applied, but as for materials that we use, they didn't work. And the chiral universality class was closed because for the first class transitions. Then we calculated 4 loops, 5 loops, and 6 loops in 3 dimensions, and it turned out that indeed it looks like that. Therefore, the fact that Andrei got hypersound weapon using this 6-loop model for Heisenberg model and started to use these Hamiltonians, that's not because he had nothing to do. This goal was set for, and it was there for several decades, and we managed to discover something here. And now a few words about Andrei. We've been working for several years in a row. He came to work with me as being a student, and his energy, his activity, and his lively interest in science really impressed me. And what is more, when we had these 6-loop results, I had a thought that we can summarize the results of Stepan's campaign on anisotropic model, and I understand that it's quite hard to do. But Andrei was really inspired, and certainly we were working quite actively, and he got quite involved, and I believe this characterizes him quite well. He took these goals, he developed them up until the end. He summed up by different methods and got this multi-dimensional, multicolor picture, and got very good results. So I can characterize him as a talented and quite inspired by science, and I hope that he will continue his scientific work, and I have no doubts that he meets all the requirements for a candidate's degree. Certainly that's a candidate of sciences with a very expressive worldview. And he graduated from the mechanics department, and he was not taught in the field. That's not his profile, not his major. That's not quantum physics, not the field theory, not elementary particles theory. So he really studied a lot of material and got these record results by himself. That's it. Thank you very much. So, I have a question. If anyone has comments that we're working in a remote mode, any comments on that? Any questions on that? Is everyone satisfied with our remote mode? With our remote defense procedure? Yes. Yes, quite satisfied. Okay. Certainly we would be pleased to come and yes, and now we discuss the results of the thesis. Overall, we can ask everyone, all the members of the board, to leave the room and to discuss everything secretly. Yet I have a question. Do you think that it's necessary? I believe there was no word against the conferring of a degree. So no, it's not mandatory. We can resolve by ourselves. Yes, we can vote already. If the rules allow, yes, we are ready. Okay. Well then, we continue our session. And here, as for procedure, we need to check the sound and the video. Does everything work? Yes, it does. Okay. Okay, then. Let us vote on the conferring of the academic degree. And we're going to have open balloting, and I give the floor to Nikolai, to Mr. Antonov. Don't forget to turn on the microphone. Certainly, I agree with the conferral of the academic degree. Dmitry Aristov, certainly. Certainly, I agree then, Mr. Prudnikov. Yes, I also support. And Michal Ignatic. Yes, I also support. And certainly, I agree with that as well. So the voting results 5 for, no one against. And therefore, a decision is being made on the conferring of the academic degree of the candidate of Sciences in Physics and Mathematics to Andrei Kudlis in Specialization 010402 Theoretical Physics. Any comments on the procedure? No comments whatsoever? Yes? No, no comments. So, we give the floor to our candidate for the final remarks. Well, I did not get ready for that. So everything was mentioned already. I would like to thank everyone who read this work. That's the first thing to be mentioned. Thank you very much for your high appraisal. Thank you very much to everyone who helped to organize everything. Thank you so much to those. Thank you so very much to Alexander Ivanovich for spending so much time and resources on me, for explaining that all to me, for helping me, and I would like to thank for this critical approach to literature, because never again did I feel such a stress when I write a letter to Alexander Ivanovich, because I check all the commas all the time, because Alexander taught me that. Therefore, I try to have it to control this descriptions in my thesis. Thank you very much, everyone, and I'm really glad that we gathered here today and everything finished well. Okay, so let's congratulate our candidate. Thank you, everyone. Yes, and we congratulate Alexander as well. Thank you very much. Thank you very much, Vladimir. I was really glad to see you and to hear you. Yes, thank you. So I believe we can turn off the broadcast.